Welcome. In this video, I'm going to demonstrate one possible strategy that can be used to convert a quadratic function that's in standard form to one that's in vertex form. We'll start with the simpler case where a is equal to 1. I'm going to be focusing on just the variable terms to complete the square. So I'm going to set up and leave a space here for what I need to add to complete the square. I know I need to take my value for b, -4, divide it equally in half, and then whatever I get there, square it. So that's going to be -2 squared, which is 4. So adding 4 completes the square. But notice by adding 4, I have just made this equation unbalanced. So to offset the addition of 4, I could either also add 4 to this side, or I could subtract 4 from the same side, because adding 4 and subtracting 4 is adding 0 and doesn't change the equation. So what we're going to have here now is f of x is equal to, I can write this now, this perfect square trinomial as a binomial squared of x minus 2 squared plus 7 minus 4, or plus 3. And I have this equation now in vertex form. I love vertex form. It's so easy to find the vertex. It's the value being subtracted from x and the value that's being added here. Next, let's look at a slightly more complex example where a is not equal to 1. Just like I did in the first case, I'm going to be completing the square, so I want to be focusing just on these variable terms. I know to complete the square, I want to get a to be 1. So here I could divide by -2, but with the f of x on one side, I'd like to be a little bit more elegant than that. So instead, I'm going to factor out a -2. And I'm just going to factor it out from those variable terms. So it's going to be -2 times x squared. -4x divided by -2 is positive 2x. And I'm going to leave a space here because I know I'm going to complete the square. All right, now to complete the square, I need to take, again, my b term, split that into half, which will give me 1, and square that. So 1 squared is also just 1. Now, I didn't add 1 to this side so far. What I've done is I've added 1 times -2. So I've added -2. Can you see that's very subtle? So to keep this equation balanced, I've added a -2, or you can think of that as I've subtracted 2 from the equation. So I need to add 2 to offset it. So now I haven't changed this equation at all. I've added a -2, I've added a positive 2, I've just added 0 and haven't changed the equation. So if this feels this is a challenging thing to think about, you might want to pause me and think what I just did there and then come back or watch it again. All right, this allows me now to write my trinomial as a perfect square, since the perfect square trinomial is a binomial squared, excuse me, and that's going to be x plus 1 squared minus 7 plus 2 minus 5. I can now quickly decode. I know my vertex is the number being subtracted from x. Another way to think of it is what makes this binomial equal to 0. So it's going to be -1, and my y value is -5. One thing I want to highlight here is our a's are the same. Notice a is -2 and a is still -2. So that doesn't change as you move from standard to vertex form. All right, there's several different ways you can complete the square to turn a quadratic function from standard form into vertex form. This is just one method that I wanted to share with you. Again, completing the square is this big idea. It's so useful whenever you have some form of trinomial that you want to get a binomial squared for that.